So this is EE542 Lab 11 Android-based IoT interactions with Node-RED, ThingsBoard and AWS IoT. So I am Kaishavi Umrethwala. I have done this with Adithya Venkat Ramanan. So first, what is Termux and Termux API? Termux is an Android terminal emulator and Linux environment app that works directly with no routing or setup required. We can run a small command line utilities or a full-featured web server directly from our Android phone. So Termux API is a common companion app to Termux. It creates an interface from Termux to your device features. With Termux API, we can take photos from our phone camera, get location from GPS, read or send SMS, and a lot of other features. We can do everything directly from the emulated Linux terminal. We have used Node-RED. So Node-RED is a flow-based development tool for visual programming developed originally by IBM for wiring together hardware devices, APIs, and online services as part of the Internet of Things. It provides a browser-based editor that makes it easy to wire together flows using the wide range of nodes in the palette that can be deployed towards a runtime in a single click. A built-in library allows you to save useful functions, templates, or flows for reuse. The flows created in Node-RED are stored in using JSON. Here, flow-based programming is a way of describing an application's behavior as a node. Each node has a well-defined purpose. It is given some data, it processes the data per the functionality with that data, and then it passes that data to next node. So the network is here. The network is responsible for the flow of data between the nodes. We implemented Node-RED, and we will see its features and everything later. AWS IoT Core. So AWS IoT provides the cloud services that connect your IoT devices to other devices and AWS cloud services. It can provide support for your compatible devices to facilitate development and integration of your devices with AWS IoT. AWS IoT communication supports MQTT and HTTPS to help you manage and support your IoT devices in the field. So there's a device gateway. It manages all active device connections and implements semantics for multiple protocols to ensure that devices are able to securely and efficiently communicate with AWS IoT Core. We have used ThingsBoard to visualize the data. Here, ThingsBoard is an open source IoT platform for data collection, processing, visualization, and device management. It enables device connectivity via industry standard IoT protocols, MQTT, web, and HTTP, and it supports the both cloud and on-premises deployments. ThingsBoard combines scalability, fault tolerance, and performance, so you will never lose your data. So now we will see how the Termux works. So here I have remote login to my Android OnePlus 7T, and now we will execute the commands given in the lab document. So let's first execute this command. It will give a list of all the sensors in my OnePlus 7T phone. We can see a lot of sensors I'm having on OnePlus 7T. Now let's get the readings of them. So it will continuously print the readings of the sensors. If you want to execute it only one time, you can write this -n and 1. So it will print only once. All the readings of the sensors will be printed only one time. Okay. Using this, we can get to know what we can do with the sensors. We can display, delay, we can limit, we can list the sensor, we can do cleanup. Now I am having this light sensor. Let's see only the reading of this light sensor, which I got from here, the list of the sensor I'm having on my phone. So it will print continuously the reading of the light sensor on my phone. We can see that.
So you can see that we are able to plot the light sensor readings on our ThingsBoard, which is running on our EC2 instances. So this is the instance that I'm using. This is the instance. I've already started the ThingsBoard. So this is my Node-RED, my PC Node-RED. So it sends an HTTP request. This request goes to ThingsBoard directly, and this goes to the IoT core. So this is one way to visualize your data by directly sending it to your ThingsBoard endpoint. Or what you could do is you could add. So you could utilize the IoT core of AWS, and then add to its rules to invoke the ThingsBeat data, so that you could do the same functionality on via the IoT core. So right now I'm just directly doing it on ThingsBoard. So it's just directly going to the ThingsBoard, right? And this is my phone data, right? So every 5 seconds it's gonna invoke this particular statement on the kernel, right? And then it's gonna do a request to my local PC IP address. Right, so that these are how my nodes are configured, and let's try some variation. So you can see if I just added a torch here, you can see a spike going up. Yeah, because I just switched on the torch on another mobile, and I'm just lighting it up on my mobile phone sensor, and I'm slowly bringing the torch away from the phone, so you can see it's dropping and dropping. Yeah, right. And now remove my torch from the sensor. Now I'm gonna cover the sensor just to see whether it's also keeping track of whether there's no incoming light. Yeah, see, you can see the dip there. So we are injecting that light sensing command every 5 seconds. You could do that to less number of seconds also. We could. So right now I've done. I'm just showing the last 2 minutes of data, and you could change this to a different time as well. So in this way you could easily visualize our incoming data in real time using Node-RED, IoT Core, and ThingsBoard for visualization. Okay, so the task that was given to us was to add a timestamp in Unix format, the date in human readable format, and to add sensor values in a human readable format and not in a JSON format on the S3 bucket. So that was one task to get basically write whatever data that we are getting on the S3 bucket, as well as taking different data, at least five different sensors. So the 5 different sensors that I've taken is the light sensor, accelerometer, magnetometer, gyroscope, and the proximity. So this is just a command line. This is the exec node which will basically execute this command. So we're using Termux API. So Termux sensor, letting know what all sensors that I need for once. right? The timestamp that I'm using is same as before, every 5 seconds, and this will then send to my local PC node. So my local PC node will pass the incoming string as JSON, and one of the requirement was to add the Unix timestamp. So I'm doing that by basically setting a separate JSON object. In the same JSON object, we're adding an additional attribute that is Unix TS, and by default, the timestamp on the node red, this gives us a Unix timestamp. So we have Unix timestamp under this, right? Now, if you can see the function, this function is basically making it in a structured way. So all my data are in the payload dot sections, right? So I'm getting my date from the Unix timestamp, and then I'm specifying what month is based on the uh, numbers, and get month gives us basically 0 for January or 1 for February. So I'm just my month array will give us a Jan Feb because the index is get month. So this dt.getMonth gives us the index of the month that we are currently in through the date function, right? So you can see that message payload date time gives us month hyphen date hyphen full year hyphen and then the time in the readable format. So this is the hours, minutes, and then seconds, right? So all this will be under payload.datetime, right? Now payload.light sensor same as before, light value 0. So accelerometer gives us the values on x-axis, y-axis, and z-axis. So that's how I'm figured x-axis, x-accelerometer, y-accelerometer, z-accelerometer, and parsing it for different indices. Same for magnetometer and same for gyroscope. So and proximity sensor similar to light sensor. It only has the first field populated. So we have our 5 sensors, that is light sensor, accelerometer, magnetometer, gyroscope, and proximity sensor, and that's how I'm form my message sequence, right? Now we have to same as before, I'm directly sending it to ThingsBoard, not via AWS IoT. So the string stream format is different for different case because that's the requirement for the task, right? And for the AWS IoT, so that it can be stored in the S3 bucket, we want it comma separated, all the values, right? So that's how I'm basically separating with using commas, and I'm using the JSON.stringify. So basically this will convert everything into a string, and that can be easily transmitted by the HTTP request node. Now for ThingsBoard, we need it in the specified format as given in the documentation. So, and right now we are injecting the timestamp as well. So our device is able to claim the client side timestamp. That's how we're doing this. So we am using the timestamp from my JSON node, and the value is based on what I want, right? So you can see here that the timestamp is the timestamp that I'm keeping track of, and the values are populated based on the key and corresponding values, right? So all these data will go to ThingsBoard. So that's why I'm creating separate functions for parsing logic for AWS IoT and ThingsBoard, right? So now let me show you the bucket. So I've already initialized my Kinesis Firehose, so it'll keep everything for 120 seconds and then populate the file, right? That's what we wanted. Now let me reload this. You can see that there will be a new directory created. Yeah. So this is based on the current date, right? So you can see 2 folders are already created. So we have these 2 files. So it will be populated based on either whether the memory buffer, that is 5 MB, is filled, or it's the what do you call, well, after 120 seconds it gets filled, right? So let me show you the actual value. So like we can see that whether the data has been currently populated. Now I'm just trying to figure out how to extract this data. Okay, download It's open. Yeah. So let me bring this up here on the different screen. Yeah. So let me full screen this. So you can see that this is our date that we intended it to be. So it's 4:56 a.m. right now, and this is our Unix timestamp. There's a light sensor. The first three are the accelerometer readings. The next three are the magnetometer readings, and the last three is the gyroscope readings. And then the final result is the proximity sensor, right? So this is what we wanted. This is how we wanted. This is our requirement. So that's why we have a separate string stream function for AWS, so that we wanted, so that we get this in this form, right? So we have this data set. Now our S3 bucket is working perfectly like how we want it. Now let's check out ThingsBoard. So I've already created the dashboards for everything. I've clubbed all the X accelerometer, Y accelerometer, and Z accelerometer in one chart. For the same for gyroscope and same for magnetometer, light sensor, and proximity sensor. Right. So you can see there are variations based on how I'm holding my mobile or how I'm moving my mobile, or whether if there's an obstruction ahead. So I'm right now covering the front phone of this thing, and you can see that there's a change in the light sensor and proximity sensor because I've kept my hand over the phone. Right? So you can get this is how you can visualize data in real time, and we can basically, this can be used for debugging purposes whether it's correctly sending or not, right? So you can see there are variations in all three based on how I'm holding the phone, how I'm moving my phone, and whether there's any obstruction in front of it, right? So this concludes the step one, that is to basically adding a timestamp on this 3 bucket file, timestamp, date, and the this thing. I'll just open it again for the reference. Yeah, no, it's not this one. I think it's this one. Yeah. So this was one of the requirements, to have our data written in the S3 bucket as different files. And the second requirement was to basically visualize all the data, all the sensor data. Right. So that concludes basically the 9th task for the demo. And thank you.